Hi guys, this is Miss Igo. Welcome to my classroom. Today we're going to be talking about probability. For basic probability, given that all outcomes are equally likely, we can compute the probability of an event E using this formula. The probability of an event is equal to the desired outcomes divided by the total possible outcomes. For example, if E is rolling a 3 on a 6-sided die, the probability is the desired outcome, which in this case would be rolling a 3. There's 1 3 on a 6-sided die. Divided by the total possible outcomes, well, there are 6 sides, of course, on a 6-sided die, so there are 6 possible outcomes. So our probability would be 1 out of 6. If our fraction can be reduced, we need to reduce our fraction. The probability that an event occurs and the probability that the event does not occur, which is called the complement of the event, add up to make one whole, or 100%. Based on our previous example of rolling a 3 on a 6-sided die, we said that probability is 1 out of 6. Well, the probability of not rolling a 3, there are 5 other sides that don't have a 3 on it out of 6 total sides. And if we add that up, that gives us 6 out of 6, which is 1 or 100%. So the probability of an event occurring plus the event that it does not occur add up to be 1. Based on that fact, we can find the probability of the complement of an event, which is notated by this right here, this bar over the E. That's the complement of E. Or we could say that that would be the probability of the event not occurring, can be found by, because of the fact that the complement plus the original event added together equal 1, we can take 1 and subtract the probability of the event occurring, and that will give us the probability of the complement of the event occurring. So if I had 1 and I subtracted the probability of the event occurring, just like in our previous example, the probability was 1 out of 6, then that would give me, if I change the 1 to a fraction, 6 out of 6 minus 1 out of 6, that gives me the 5 out of 6, which is the probability of the complement. Now let's talk about the probability of A and B for independent events. First, let's stop and talk about what independent events would be. Independent events mean that one event does not affect the outcome of the other event. For example, if I roll a die twice, whatever I roll the first time is not going to affect what I roll the second time. So, to find the probability of A and B, we simply multiply the two probabilities together. So suppose we flipped a coin and we rolled a die, and we wanted to know the probability of getting a head on the coin and a 6 on the die. Well, the probability of getting a head on the coin is 1 out of 2, because there is one head on a coin, but there are 2 sides. So the probability is 1 out of 2. The probability of rolling a 6 on a die is there's only 1 6 on a 6-sided die, and there are 6 sides. So we just take these two probabilities and multiply them together, and we get 1 out of 12. Now the thing you need to remember here is the word and. So if we are trying to determine the probability of one event and another event happening, we multiply the two together. To find the probability of one event or the other event happening, We take the probability of the first event plus the probability of the second event and subtract any overlapping events. I'll show you what I mean by this example. Suppose we flipped a coin and rolled a die and we wanted to know the probability of getting a head on the coin or a 6 on the die. So this is different than the example that we used earlier where it said and. So this time we want to know what is the probability of either getting a head on the coin or a 6 on the die. So first I'm going to list out the different possible combinations of flips and rolls that we could get. So here are all the total possible combinations. If in one try we flip a head and roll a 1, that's our first event. And then this one would be if we flipped a head and rolled a 2 and so on. Here these are if we flipped a tail and rolled a 1 and so on. So there are 12 different possible combinations. We can determine the total number of outcomes by multiplying the total number of outcomes for each event. So for flipping a coin, there are 2 possibilities. We could flip a head or a tail. For the die, there are 6 possibilities. We could get a 1, 2, 3, 4, 5, or a 6. If we multiply those together, we get 12. So that means there are 12 possible combinations when we combine the two. So if you count all of these different combinations, it comes up to be 12. So that's how we know we have all of the different possible combinations. Now, to determine what is the probability of getting a head on the coin or a 6 on the die, if we count up our different possibilities, we would get, all of these are heads, so that fits in the criteria of what we want. So this is 1, 2, 3, 4, 5, 6 heads. And for the die, we're trying to roll a 6 on the die. Well, here is one event where we rolled a 6, and here is another one. So if we counted all of those up, we would get 1, 2, 3, 4, 5, 6 heads and 1, 2 sixes. So that would give us 8. But we would be counting this outcome twice because we counted it once when we were counting all the heads and we counted it again when we were counting the sixes. So this is the overlapping outcome. So that's why when we try to determine how many or what the probability is when it's event A or event B, we have to subtract the overlapping outcome. So based on our formula, the probability of A, which is getting a head on the coin, is 1 out of 2 because there's one head out of 2 sides, plus the probability of rolling a 6 on the die is 1 out of 6 because there is 1 6 on a 6-sided die. And then we have to subtract the overlapping outcome. Well, there were 12 total outcomes and there was one that overlapped, so that's 1 out of 12. Okay, so we can either put this in our calculator as it is, or we could get a common denominator and work this out. So with a common denominator, this would be 6 out of 12 plus 2 out of 12 minus 1 out of 12. Okay, so 6 plus 2 is 8, minus 1 is 7 out of 12. So the probability of getting a head on the coin or a 6 on the die is 7 out of 12. Let's try that same thing with another example. Suppose you draw one card from a deck of cards. What is the probability that the card is a red card or an ace? So first of all, what is the probability that you draw a red card? Well, there are 52 cards in a deck of cards, and half of them are red. So that means the probability would be 26 out of 52. We could reduce that and get 1/2, but I'm going to leave it like that for right now. The probability of getting an ace out of a deck of cards. First of all, how many aces are in a deck of cards? There are 4 aces in a deck of 52 cards. So to get the probability that when we draw one card out of a deck, we get either a red card or an ace, we would add these two together, but then we would have to subtract any that overlap. Are there any red aces? Yes, there are 4 aces, one from each suit. So there's the ace of diamonds and the ace of hearts that are both red. And then we have the ace of clubs and the ace of spades that are black. So that means there are 2 aces that are red, 2 out of the 52. So now we're going to add all this up. 26 plus 4 is 30, and then 30 minus 2 is 28, and that's out of 52. And like I said before, always reduce your fractions. So this would reduce to 7 out of 13. Now, suppose we draw one card from a standard deck. What is the probability that we draw a queen or a king? Well, what is the probability that we draw a queen? Just like with the aces, there are 4 queens in a deck of cards, and there are 52 cards total. For the kings, there are 4 kings out of the 52 cards. Are there any king-queen cards? No. So there are no overlapping events. So we would subtract 0. So this gives us 4 plus 4, which is 8, out of 52 cards, and that would reduce to 2 out of 13. When one outcome is dependent upon the other, it's called conditional probability. So in conditional probability, the probability of A and B is equal to the probability of A times the probability of B given A. So that's how we read this B bar A. It's B given A. And what that means is we're multiplying the probability of A times the probability of B as long as A happened, or given that A happened. For example, what is the probability that 2 cards drawn at random from a deck of playing cards will both be jacks? So there are 2 events happening here. We're going to draw 2 cards. When we draw the first card, what is the probability that that first card is a jack? Well, how many jacks are there in a deck of cards? There's 4. And there are 52 cards total. Well, if I draw a jack that first time that I draw cards, and I hold on to that card, the next time I go to draw, there are no longer 4 jacks left if I drew a jack the first time. So there are now only 3 jacks left in the deck. There are also no longer 52 cards total. Because I drew a card and I kept it, there are now only 51 cards total. So we're going to multiply those together. And when we reduce our fraction, we would get 1 out of 221. Let's look at conditional probability when using a table or a chart. A home pregnancy test was given to women. Then pregnancy was verified through blood tests. The following table shows the home pregnancy test results. Number 1, find the women that are not pregnant given they had a positive test result. When we are looking for the probability and we have a given, we're going to concentrate on that first. So we look at the given, and that's going to tell us what row or column to look in. So the given is a positive test result. Well, positive test result is this column right here. So we're going to only be concentrating on this column here. Now we want to know those that were not pregnant given the positive test result. So looking at the positive test results, the ones that were not pregnant is this right here. So the probability of those that were not pregnant given a positive test result is 5 out of the total that were positive test results of 75. And that reduces to 1 out of 15. Number 2 says the probability of having a positive test result given they were not pregnant. So, like I said before, we look at the given first, then not pregnant. And when I look at my chart, not pregnant is this row. So we're going to concentrate on just this row. And we want the ones that had a positive test result. So that would be 5 out of the total of 19. And that won't reduce. So notice that even though these statements are the same, they're just reversed. Not pregnant given a positive test result, or positive test result given they're not pregnant. They don't give us the same result. So it's very important that you pay attention to which one is the given in the statement. If you like this video, be sure to click the like button below. If you haven't already done so, be sure to subscribe to my channel. Also, if this video helped you, make sure that you share it with your classmates. Thank you for watching.